Today we're going to talk about Newton's laws of motion. So who was Newton? Sir Isaac Newton was a scientist who lived in the 16 and early 1700s. He lived in England and was a professor at Cambridge University and became the president of the Royal Society. He was a polymath, someone very good in many fields, and he is best known for his revolutionary contributions to mathematics, optics, gravitation, and mechanics. In mechanics, he used his own mathematical invention, calculus, to develop his three very famous laws of motion, which explain how objects move and react to forces. The first law of motion states that an object that is at rest will stay at rest unless a force is applied. It also states that an object in motion will keep moving in the same direction until a force is applied. When we talk of force applied, we must remember that it is net force that is important. When we push something, there is friction which counteracts our efforts. A falling object will have air resistance slowing the acceleration to a terminal velocity. You have to subtract the resisting force from the applied force to get the net force. The second law of motion states that if there is a net force, there will be acceleration proportional to the mass of the object. This is expressed in the famous formula F equals ma. F is the net force. That is the force doing the pushing or pulling, minus any friction, air resistance, or other force trying to prevent the object from moving. And the acceleration that results is a, measured in meters per second per second. The m is the mass of the object in kilograms. Notice that I said the mass and not weight. The weight of an object is the force gravity exerts on the object. It is proportional to the object's mass, but not the same. The third law of motion states that if a force is applied to an object, there is an opposite and equal reaction force pushing back against whatever is applying the force. When you push against a wall, you feel a push back from the wall exactly equal to the force you are applying to the wall. When you jump, you are feeling the earth push you up, but at the same time you are pushing the earth down. But because the mass of the earth is so very much greater than yours, the resultant acceleration of the earth downwards is extremely small compared to the acceleration you gain when you jump. Without Newton's laws of motion, we would never have had the Industrial Revolution. We'll talk more about them in a later video.